Well, everybody, thank you so much for joining my session today. Really appreciate you coming in the afternoon. I know it's Thursday and at the sort of the back half of the week here, and I know everybody's probably getting a little tired, so hopefully we'll have some good content for you here, and I'm sure you're all sort of looking forward to replay later today. As the slide says here, my name's Todd Golding, and I'm a partner solutions architect at AWS, and I'm part of a team that's called the SaaS Factory. And you may have heard of our team before, but we've basically been building and delivering and optimizing SaaS solutions for the last 5 or 6 years and developing patterns and strategies to just try to identify best practices, and certainly sharing a lot of that here at reInvent. And in the early days, and this still continues to this date, migration has been a huge issue for SaaS organizations. We continue to come into company after company that has some system they've built. It may be a legacy system, it may be a somewhat modernized system, but it's not sort of running in a multi-tenant SaaS model. And those organizations are often highly motivated to figure out how can they take their current solution and move it into a SaaS delivery model. And they're really after all the goodness that comes with SaaS. They're really wanting to get all the innovation and the agility, the cost efficiency. Often it's even just about cost efficiency. But they also, there's operational impacts on agility that are all part of the promise of moving to SaaS. And it's been our job to go in a lot of times these organizations, try to help them figure out what's the right journey for them to follow. How do we sort of take all the inputs from their business and figure out where they should start, what should their target sort of technology strategy, and what should that transformation path look like? And I will say that transformation path, I know we're here in a tech context, is a business transformation for these organizations. We aren't just transforming their tech, we are transforming their business. Now we're going to focus on the tech dimension of that today more, but whatever you do, if you leave a modernization or a migration talk about SaaS with me, make sure you understand, I know that there are huge sort of business components to this as well. And so in the past, I have put content around this topic together that looked at more like broad patterns and strategies. So what are just some of the sort of common themes for how people could approach it, and what were sort of common ways that I've seen customers approach this, just to give us sort of a wide spectrum of possibilities. And I thought, for this year's reInvent, I thought, well, instead of sort of being general about all these different strategies, what if we just took a slice of a strategy and kind of walked it end to end, with the idea that you'd see how that one strategy works end to end, but you'd also see across that probably relatable concepts for yourself. You could say, oh, I see how this would sort of unfold for my particular environment. So that is the goal of this talk today. I hope that aligns with kind of what the abstract said for you and the reason you showed up today. I'll also say this is a 300 level topic. Yes, we're going to look at architecture. Yes, we're going to look at a little bit of code, but we're not cracking open the IDE. We're not going to write and do a whole transformation in this session now. It's not a 400 level topic, so just want to make sure I'm setting your expectations here. Okay, so if we're going to talk about migration, the migration story has to start somewhere, and I have to pick some kind of architecture to say where are we starting from. I would not be too literal about what's in this slide. You may be somewhat microservices today. You might have a slightly different look of this. But I work with an awful lot of customers who have some variation of this architecture as their starting point for their move to SaaS. There's some kind of N-tier architecture. They've got a web app. They've got an app tier. And they've got some kind of storage. And in the app tier, they've maybe built some services. They've kind of got some notion. This might be service-oriented architecture sort of days. It might actually be microservices. And then they've got frameworks and tools in there. And in the app tier, I tend to find that these things end up being somewhat tightly coupled to one another. But really, even the bigger challenge of these environments is that when you get down to that storage level, a lot of these environments have some kind of monolithic database here. And the app tier has had the privilege of basically being able to say, yeah, we wrote all these services, but they bind to the database and consume anything and everything they want out of that database. And in some cases, we even have stored procs here. We'll have stored procs where some of the business logic that was up in that app tier might have got pushed down historically over there. Now, probably more modern solutions have a slightly different flavor of this. Maybe more legacy-ish kind of solutions look a little more like what I have on the board here. Either way, the assumption is we're starting with something that maybe isn't entirely decomposed isn't entirely modernized at this point, and our goal is to get it to SaaS. Maybe the most important thing is, even if it's fully microservice-based, it's not multi-tenant at this point. And so we got to figure out how we get this to SaaS. Now, when we talk about this, I also want to highlight one of the features of these environments is that they are also often deployed in a very sort of coarse-grained manner. Usually we'll say, oh, for these environments, we're going to sort of take the entire app tier and the web tier, or some big portion of this, our CI/CD process, we'll build it all up. We'll then deploy that as some big unit, like the entire application will get deployed, and then it'll go through some QA, and then eventually it'll get in the hands of the customer. And this usually means we're not going to deploy it quite as frequently. And it also means the blast radius of whatever we deploy is probably going to be a little wider here because we're deploying in bigger chunks. So as part of moving to SaaS, not only do we want to sort of modernize this application and get it running in a multi-tenant model, but we'd like to get to a mode where we could release in smaller pieces, because that's certainly a big part of our operational efficiency story and our agility that we're after as a SaaS organization. Now, the biggest and the hardest part of this discussion is like deciding what kind of path you're going to take, what your journey's going to look like, and which strategy you're going to choose as a migration. And to me, there are two very extreme options to consider here that people will often look at, and I will also acknowledge there's all kinds of flavors in between. But let's just look at the extremes for the moment. On one end, some organizations will say, well, we're going to migrate to SaaS, but we really feel like we're not feeling competitive pressure from the market. We have a captive audience, so yes, we want to get to SaaS, but we're going to take some time to kind of go away, rewrite, and rethink, and not immediately move to SaaS. Sorry, tripping over myself for a second there. We're not going to rush to SaaS. We're sort of going to take our time. We're going to take the luxury of that time and build a solution that really is the sort of modernized version of our product. And that's a perfectly reasonable strategy, but there's a challenge to that, which is there's a lot of time that goes by while you're in that phase, and it's usually a tech-centered model. In that space, you're mostly thinking about how's the tech transforming. But if you remember at the beginning here, I said the move to SaaS is also a business transformation. So when we're transforming, we're not just transforming the tech. We're going to sell it differently. We're going to probably market it differently. We're going to bill for it differently. We got to build all of these other bits of the organization and get them to come along with us. And if we take a very long time to build this product, those parts of the organization are not going to be evolving. They're not going to be transforming a whole lot. So they're kind of delayed in their start, and they're going to wait this very long window before they get started on that transformation. The more important part of this, customers are not going to be part of this loop during this time that you're building. You're going to have no feedback from customers on, are you building the right thing? Is your flavor of SaaS product really what they want? Is your pricing model really working the way you want it to work? You want feedback from customers as soon as you possibly can get it. So to me, the delay of all that is pretty expensive delay. Now, it does come at the luxury of maybe moving the modernization needle a little faster than it would otherwise, but it can be challenging. Now, the alternative to this, and I'm sort of tipped my hand probably to where I'm going to lean in this story, is a model where we would say migrate as soon as possible. Like, get something up and running in a SaaS model as soon as possible. Yes, there'll be technical debt to that. Yes, there'll be complexity to that you probably don't want to absorb. But to me, the fact that I can start selling my product, even with sort of these technical difficulties attached to it, in a SaaS model, lets my business begin to operate against that model. It lets sales and marketing and customer success and all these parts of the organization start to move. And it also lets us start to engage the customer sooner in terms of, do they like our SaaS product? Do they not like our SaaS product? And so to me, when you look at these two extremes, I favor a model that says get to SaaS as soon as you can and then begin to incrementally modernize. So it's not that we're trading this model for not modernizing the solution. We're just going to accept the fact that modernization is going to happen in more incremental fashion, and we're going to trade that for letting the business be able to sell and operate in a SaaS model. Again, lots of gray area in here where you could choose different variations of this, but I would say generally if you're going to go on that top model, you should have a pretty compelling reason to be up there. Otherwise, I'd lean towards the bottom. Okay, so enough about the sort of foundational bits of why we're going where we're going and where we're starting, let's look at what we want to get to. And this slide is a generic sort of, this is like what we would show to anybody at the highest level to say, hey, I'm going to go build a SaaS solution. What do I want it to look like when I'm all done? Obviously, lots of detail missing here that we would have if we had more room. But essentially what you're going to see is the two halves of SaaS that we talk about all the time, the control plane and an application plane. And these two halves of SaaS are going to be essential to your migration story. In this control plane is where we're going to build all the horizontal bits that are needed to manage, operate, onboard, bill your tenants. These are all the components that are needed to really build a SaaS business. And for most people migrating, they don't have a control plane at all today. These services don't exist at all, right? And so in fact, a big part of your migration is going to be, and you'll see as we go through these slides, is going to be about defining what that control plane looks like and what needs to be in it and starting to build the parts of that so that we actually bring multi-tenancy to our application. Now on the left-hand side is, and again, I had to generalize a lot to fit it in the slide here, is where the actual business services of our application. This is where the microservices are. This is where we're going to do tenant isolation, data partitioning. This is where we're going to deal with all the complexities of interesting deployment models and routing, all the stuff we talk about that happens inside the application. It's going to land there, and ultimately at the end of our migration, we want to land in a model where it's fully modernized and we have all the goodness of what it means to have a multi-tenant environment here. What we're going to find is that on that left-hand side, we're going to have to make a lot of compromises to be able to sort of make these intermediate steps that'll allow us to get to SaaS. Where we don't want to compromise is on the right-hand side. You don't have to build this huge, heavyweight control plane on day one, but you shouldn't underinvest in that control plane. It is the foundation of not just the early and the first sort of MVP of your migration, it is the long-term control plane that you're going to have for your entire service, even when it's fully modernized. Now, the model we're going to choose here is, and there's no surprises here, is what I call the full stack silo model. If we're going to try to get to market as soon as we possibly can, our goal is to say, how can we take our existing application and in the least invasive way possible, pick that application up and move it into this SaaS model. And the best option we have for that is the full stack model. And the full stack silo model says basically every tenant is going to run in an entirely separate model here. This could be, we're going to look at this, but AWS offers lots of ways to do this. We're going to look at a way to do this with EKS. But the key here is that each tenant has dedicated infrastructure, and because it has dedicated infrastructure, suddenly we don't have to go rewrite all the services. We don't have to replumb everything to get everything to work with multi-tenancy. Now, the natural question to ask here is, like, is that really SaaS? Like, customers aren't sharing any resources. Customers are all running dedicated infrastructure. And my answer would be a resounding yes, this is still SaaS. In fact, there are businesses today who start from scratch and build their solution like this because of the compliance requirements or because of noisy neighbor or any number of different reasons, or parts of their system will end up being dedicated to tenants. So don't think because we don't have shared infrastructure, we somehow don't have SaaS. What really makes this SaaS is that control plane on the right-hand side. Because that control plane is going to say, we onboard all these tenants through the same process. We have a single way of authenticating tenants into this environment and injecting tenant context into that application. We have a single place where we bill for all of this. And no matter what that stack on the left-hand side looks like, it's still going to be managed and operated by this control plane. Now, the key to all of this, and the place where sometimes people will interpret this slide wrong, is they'll say, oh, we got a full stack per tenant. Well, I'm going to run tenant 1 on version 1, and I'm going to run tenant 2 on version 1.2, because they don't want to come to the latest version all the time. And we're going to treat these customers as separate environments. That is the slow path to death for your SaaS solution. That is the wrong way out of the gate. One of the most important values you have to have across this migration experience is that all tenants get the same version of the product. And when I deploy an update to some microservice or some piece of the system here, all tenants get that experience. And that will be critical as we begin to evolve this solution. Okay, so those are the foundational bits. Now let's start to walk through this piece by piece. And the first place we have to start, of course, is with that control plane. Before we can even start thinking about how our application moves in, we have to start introducing the notion of tenancy and onboarding and some of these bits into our environment. And so what we're going to do here is just build a really lightweight control plane. Right? We're just going to go out and say, hey, we're going to create an onboarding service. And that onboarding service will let us take a tenant. We'll get a tier and a tenant admin user, and we'll get and the basic information we need about that tenant to create them. And then that onboarding process will go out to a tenant management service. These are microservices inside of your control plane, and tenant management is a separate service. And tenant management's just going to do something real simple right now. It's just going to go to DynamoDB, and it's going to record this information about the tenant. At first, this tenant management service will seem super basic to the point like, do I really need that to be a separate microservice? It doesn't really do anything. But as your service evolves, and if you look at our reference architectures, lots more data will go in that tenant management service. And tenant management has a role beyond onboarding. You'll find that as our admin experience, and we build out our admin experience, that it will actually come in here and it will look at tenant management, and it will get the whole list of tenants. It will let us modify are they active, inactive. It'll let us manage them and configure their policies. So it plays a role well beyond this moment. The other thing we have to do here is get a user created. Somehow you've got to auth your new tenant and get them into the system. So we have to go out here and create our new user. So what we're going to do is go out with Cognito in this example. Don't get too hung up on whether it's Cognito or not. If you want to use Okta or Ping or whatever OIDC or compliance sort of provider you want to use, create this user. Here I put them in a user pool, which is just a Cognito way of grouping users. And the most important thing here is I use custom claims, an OIDC concept, which is just property value pairs. And here I'm going to take that tenant ID and their tier and their role, and I'm going to shove those into those property value pairs. And I'm going to be able to now, when I auth, I'm going to get back a token that has your tenant context embedded in it. And that may seem like a very minimal thing. So what? I got a JOT token back and that piece of data is in there. That's how you're going to flow tenant context across this experience at the beginning of the migration all the way through this experience. It'll be essential when we get to the downstream microservices we're going to build, that JOT token becomes the gold that sort of connects a lot of these concepts. Now, if we just take a peek inside, I just want to show you, this is grabbed out of one of our reference architectures, just to show you really sort of like, these are really lightweight services. Just going to go out, this is register a tenant. It's going to create the tenant. It's going to create the user. No magic here, just basic sort of dev here. And you'll see here's the tenant, creation of the actual tenant, gets the URL of the tenant, calls that service, and takes those tenant details, posts it. They get put into DynamoDB. So nothing super exotic here at this point, pretty straightforward, pretty lightweight services. Now the next thing we have to think about is, great, we wrote these services, we have these new services, they're not running anywhere at this point. We've got the code for these services written, but we haven't talked about how they land in the infrastructure. And what you're going to see here, and for this example, I've chosen EKS not because EKS is the ultimate way to build all SaaS solutions or migrate all of them, but there are some mechanisms in EKS that make this migration story a little easier, but this could be a Lambda story, this could be an ECS story. Don't get hung up on too much on the fact that it's EKS. So I'm going to take these services and I'm going to actually containerize them. I'm going to push the image for these new services into an ECR repository to indicate, hey, they're ready to deploy. They've been written, the code's here, it's ready to function, got what I need. Now I actually have to start to provision the environment. And we talk about, first of all, this idea of baseline provisioning. Here it's done with CDK, could be done with Terraform, could be done with any number of tools you have here. And I'm going to set up your environment. And the first thing, of course, I have to do, this diagram was probably shown 100 times at reInvent while I was here, is I've got to have a multi-AZ VPC here so that I can just get high availability and sort of conform to best practices. But then now inside of here, I have to decide, where are these control plane services going to run? Where do they land inside of EKS? And in this particular example, got control plane provisioning. It's going to go out and create a namespace for the control plane. Now, I could have easily said, I'm going to run the control plane in an entirely separate cluster if I want, but in this particular example, I'm going to run the control plane in one namespace and the tenants and namespaces in the same cluster. Both are valid. I could run it in a separate cluster if I want. But by the way, in this control plane provisioning, is a lot of voodoo that has to happen to get these control planes done, because with Kubernetes, we have to run kube control commands and other commands here to create namespaces, set up environments. If you're not familiar with Kubernetes, don't worry about it too much as there's a little bit of an interesting DevOps story for how you kind of wire all this stuff together. If you look at our EKS reference architecture, you'll kind of see how that works. Now that we have the namespace there, we're ready to deploy our services into that namespace. So now we have these things in Kubernetes that are called manifests, that are like just configuration files that tell us what our service is, where it's going to pull it from this repository, what port it has, and so on. We'll look at that shortly. But after I do that and I run that service deployment and I run the commands, the EKS commands here to configure and deploy these bits, my services will now be deployed into my control plane. And now I have the baseline of my control plane environment up and running. Now, the other piece of this that I sort of left out, because I wanted to address it separately, is this, and this gets, I would say, overlooked by 80% of the people I work with, is this notion of a system admin user. So far, we talked about how a tenant comes in and how we create that tenant user, but at the same time, you need a user that is the SaaS provider's user, the people in your organization that needs to log in and manage all of your tenant environments, configure all of your tenant environments, and we need identity for that as well. So typically in our control plane, we'll have some separate admin user management, and I'll show you that in a moment, but there's nothing special about it as much as part of setting up this environment. I'm not just setting up onboarding tenant management and tenant user management, I'm also configuring and setting up this admin user management and setting up an identity provider. This could be another user pool, it could be another mechanism, but it is entirely separate from tenant management. Okay, so now I have like the foundations of this. For me, just maybe the developer and me, this is a natural moment to say, let's see it all kind of like, are the basics working here? I honestly feel like people are building multi-tenant and building the control plane. I would love to see people write more sort of just automation around this and scripting and testing around this, because like onboarding itself, like beyond this migration moment, you're going to want to have all kinds of tests to verify that this onboarding is doing what it's doing. Right now, this is probably more of a sanity test to just illustrate what we've achieved. So here I have my control plane. I've got the 3 services deployed. As a developer, I can come along, issue some kind of curl command to this service, and that will now trigger all the creation of the tenant. It'll create the user, and as we look forward, it'll actually trigger a lot more than that. But right now, those are the only 2 things we have on our control plane. So now I can come back and authenticate that user, that new tenant, I should say. I'm exercising all this as a developer, but I'm simulating a tenant experience. So I simulate the onboarding of the tenant, and now simulate the authentication of the tenant. And now I can get that JOT token back. I can crack open that JOT token and look at it and see, hey, does all my tenant context, did everything get written in there? Are all the moving parts there? Hooray, that worked. And then the last piece here relates to going out and seeing all the tenants in the system. And to make that work, we need this new admin user management that I talked about on the previous slide. I've turned that from gray to blue to show you that that's in the control plane now. And now I can come back as an admin user and say, get me a list of all the tenants that are in the system. And that's an admin level operation. So now I'm illustrating that both the tenant authentication experience is working and the system admin experience is working. And so I could sit here and onboard 10 tenants, go down and go through that admin experience, get 10 tenants back, and just see that like the fundamental plumbing of this is all in place. By no means do I think we are like inventing anything crazy hard or difficult here. We're just putting the core building blocks in place that are going to be kind of grow and mature as we go forward. All right, now we have to talk about tenant context and how we actually add it to our experience, because and how or if we should add it and where we should add it when we're in this migration sort of mindset. And this to me is probably one of the most controversial parts and most discussed parts of the migration, which is, okay, I have an existing solution. It's already running. I'm going to run it as a full stack silo. It already has identity. It already can log in. I have people already log into it. Can't I just pick that whole thing up and run it in the silo and leave it alone? And the answer is you could, but you are not going to be able to have much visibility into what tenants are. Like, you have to imagine you have your control plane that's managing this whole environment. That control plane is your view into what tenants are doing, how they're consuming the environment, how you troubleshoot and operate the environment. If you don't have some notion of tenant context embedded in this application as you bring it in, and you need to go figure out what's going on, you're just going to have to like wander across the logs and hope you can find out what's going on for what tenant. There's really no tenant context if you just bring it forward. Now, you could argue that's okay, and that might be okay, but from my standpoint, I'm going to argue that we want to get tenant context injected into that full stack silo and at least retrofit that environment somewhat and let it send some more tenant context and some more information back to our control plane about what's really going on a tenant by tenant basis. So to do that, though, we need our identity provider to support some notion of tenant context. And if you have an existing one, it may be that you can't introduce custom claims, or that mechanism may not work. Now, in reality, maybe it would, and maybe you could just introduce it there. But for this scenario, I'm going to say, I'm going to abandon my current identity provider, and I'm going to go and add a Cognito. I'm going to sort of migrate over to this authentication experience that we've already built around user management. As part of this, I have to go to tenant management first, look up what user pool you're authenticating against. If one of the pieces of data, I didn't put it in the diagram, but one of the pieces of data you record in that tenant management is which user pool this tenant's associated with. Then I'm going to go authenticate you against that Cognito user pool, and back will come my token with the tenant context, and that tenant context will be injected now into my stack. Now, the stack itself at this stage doesn't know anything about it, doesn't know what to do with it, but it's there, and now it just becomes our job to say, what are we going to do with it? To what extent are we going to apply it? So here's an example of how or where I might apply it. If you look on the left-hand side here, you'll see my application plane. I've got whatever services I've got running that came over from my existing application. And I've decided, like, I need insights into what tenants are doing. Or imagine you've got 10 silos running, and those 10 silos are running, and I've got this control plane, but that control plane, what data am I sending that control plane about what's going on in the left-hand side? I need to send it data with tenant context so that it knows which tenants are doing which things. So here's two of the common areas I see. The easiest, simplest one is log aggregation. I don't want my logs just to be logs. I want my logs to have tenant context in them, tier, tenant ID, and all that other tenant information that's in my JOT token, so that when I go and I look through my logs, at a minimum, I can pull them up and say, show me what's going on with tenant one, and I'll see just the logs for tenant one. Imagine doing that if you don't go add this tenant context into your existing solution. You're just going to go hunting and hope that you figure out what tenants are doing. I can even go say what's going on for tenants of a certain tier, potentially, if there's a problem, although I think that would be less valuable here. But we're also setting the stage for the longer term here, which is that data will be even more important as we get to the fully modernized version of this. The other one is maybe more controversial, but metrics tell you not just what's going on in your system, it's telling you how tenants are using your system and what patterns are they using it, how it's scaling. So we want you to collect really good insights that have tenant level context to attach to them so that you can say these tenants are using these features, and when they're using these features, we're seeing these kinds of activities or scaling issues or whatever's going on, so that I can actually let product owners and let the business and let the actual operations and architects have insights into what's going on here. So for me, this is the most underinvested area of SaaS. Even if you started greenfield, not enough people are publishing enough metrics. So here you don't have to go crazy and publish a ton of metrics because it is being injected into your old code, but you ought to at least pick key places in your application and say, let's get in the habit of sending some of this activity information over to our control plane. And you can imagine now our control plane has suddenly got way more value for us the more we start to add this information into it. Now, one way you can try to minimize, right, the last thing we want is builders going back and going into our existing code and just rewriting everything to add all this sort of tenant context in and the handling of this tenant context. So one of the things we do is just what any good architect or developer would do is just say, how can we introduce helpers or code here that would sort of abstract away some of the detail of injecting this tenant context. So we're going to create some helpers here. We're going to put them into a library. This can be done via an EKS. You saw a sidecar. I sort of didn't call out what that sidecar was, but in EKS we get a mesh and we can use the sidecar, and the sidecar can intercept my requests. So for example, the sidecar, if I want to log, could intercept a log message, inject the tenant context, and then send it along to the control plane. If I'm in Lambda, I can do Lambda layers, and I can put these libraries in layers, and then all my libraries will have access to it, or I can do wrappers, for example, around Lambda functions. So here, if I want to log a message, my hope is that my service, that's my existing service that already exists, my log message, my developers are just say log just like they've always said log, but they pass through this context of the jot to this log manager. The log manager can go out and say, hey, token manager, unpack this jot, get me the tenant ID, and then I'll send that log message along to the log aggregation in the control plane that will aggregate and have this centralized sort of aggregation of all my tenant context. Same thing with the metrics. If I want to record a metric from that code, simple line to record a metric. This is probably net new if you're not recording metrics today, but it'll take care of all the handling of the tenant context. And then the last one here, if you, at some point, we've got to talk about this new solution, having a new billing model and potentially integrating with a billing system. Now as I start recording activity for this tenant, and I want to say, tell the billing system, like, here's a metric that is a billing metric, I want to have these helpers to do this as well. So this is just basic good development, which is build helpers. We'd have built these might in fact already exist in your existing code, but we absolutely want to do as much as we can to make this as seamless as possible for those builders so that we're not like just rewriting all of these existing services. Otherwise, that kind of defeats our whole move fast, migrate fast strategy. Now, if you just look at in some code, just what this looks like, this is pulled out of another solution. You'll see here we just say there's a request that gets passed in. The request has the token in it. This one is saving an order, and it essentially gets the tenant ID using a token manager. The token manager is the thing I want you to focus on. I just call the token manager. The token manager unpacks the JOT token, gives me back the tenant ID. Also, you'll see down below I have this log message. There's nothing exotic in that log message at all. But at the same time, because that log manager is written as a helper, I can now sort of have it pick up the log message, inject the tenant context, inject the tenant tier. So I'm just really trying to keep this as lightweight as I can for developers. So the open question here, and there's no absolute answer to this, but the balance of this is, how do I add enough to my siloed environment that I have good operational views into what's going on inside the control plane without sort of rewriting all of these services inside of my application plane to achieve that. If I find myself just totally rewriting those application plane pieces, I've missed. I might as well have gone to the go dark, go rewrite strategy because I'm already rewriting to some degree. So you have to find that balance. I can't tell you where it is because it depends a lot on your code base, but this is the question you ought to be asking yourself. Now, the other piece of this, so far we've got our sort of our control plane up and running. We've built the helpers and the libraries to help our services be able to send the data we need to send to that control plane so that we have tenant context flowing there. But we really haven't said what it means to bring these tenant environments to life inside this infrastructure. We know they want them to run in a silo, but what does that actually look like? Well, the first step in this process is you have to containerize that application, right? Because we're going to do this in EKS. For EKS to be able to run this, we've got to have an image. Now, the good news is almost all the technology stacks, well, I shouldn't say all, but a lot of the technology stacks have a pretty straightforward mechanism and set of tools that will let you containerize them. In fact, we've got a tool called SAS Boost that sort of follows this pattern, and it basically runs full stack siloed SAS environments, and it requires people to bring in their code via containers, and we've had quite a bit of luck with that. So take your code, whatever shaper it is, microservices, monolith, whatever it is, containerize it, get it into a repo, and the key here is Obviously, this is all part of some broader CI/CD process that I just don't have time to dig into on the DevOps. Pretty much everywhere where I'm talking about containerizing something, I'm assuming somebody can build, that can check in, that's going to kick off your traditional CI/CD process, and that CI/CD process is going to know how to containerize these things and push them to the repo. Once they're pushed to the repo, then EKS kicks in for us and our manifests kick in for us, and they'll deploy from the repo into our EKS environments. Now, what's involved then in provisioning these full stack siloed environments? Well, we already have our sort of EKS cluster here. We have one namespace that's running our control plane. But now our tenant comes in, they hit that same onboarding service, and we need a new service inside our control plane that I'd call provisioning. And we want to keep onboarding and provisioning as separate concepts inside your control plane, because how you provision and what provisioning looks like today might not look the same today, but onboarding, like as the orchestrator of all that, it probably will stay pretty consistent for a lot of the life of the control plane. So now this provisioning, basically in this example, goes out and runs AWS code pipeline, the way to kick off a job to essentially go do the deployment. And here you'll see that we're going to run a series of commands. And kube control is just the sort of command line tool that we use inside of EKS to configure our environment. And you'll see that that we have this build spec YAML, and build spec YAML is just what code pipeline wants you to call that file. That is the configuration file for executing your code pipeline. And we'll dig inside what's in there, but at its core, it's essentially going to create the namespace, and it's going to configure the namespace with IAM roles, and then it's going to deploy our application services to that environment. But at the bottom, you also see I just have this generic service.yaml. I don't know what service, I tried not to map this to any concrete service. You would have separate files, separate YAML files there for each one of your services that are inside of this. If you have one giant one, or you have 5, or whatever it is. And here, this lets you configure the scale of these independently. So I can configure scaling from one service different than another service. So when I run this, it'll essentially create the namespace for a tenant. It'll create those services, it'll deploy them, create another one, it'll create another namespace. And then obviously the code, that is the actual images we containerized in the previous slide, sitting in that repo, gets deployed to these containers that are running inside of our cluster. And here our namespace is our unit of, our silo unit, if you will. If we were in another stack, these could be VPCs, these could be accounts, kind of depends on how you want to do it. But in this particular model, because I'm in EKS, I chose to use namespace for each individual tenant. I will add the caveat that if you're doing this for thousands of tenants, there's a point at which you're going to hit limits. You might have to do this with pods. You might have to, there are other points at which this silo model doesn't scale as good as we want, so you do have to factor that into your thinking. Now, the other thing is we have to automate this application, like this build spec. I talked about these commands. If we were to open up that build spec, I'm just showing you the kube control commands. We create the namespace, and then I just have a service 1 and a service 2. But this is basically taking the manifests that describe the configurations of these services, and we'll look at those manifests in maybe the next slide, I think it is. And that tells me how that service is configured. And I did it for 2 services here, so we're just repeating this for each of the services. Pretty straightforward stuff. Now, if we look at the YAML, like I said, we look at the manifest for this. I have suppose this was an order service. I wanted to name these services. For our manifest, we have a deployment, and that gets set up. If you're familiar with this, it is just all the configuration of essentially how it's here, how our service is going to be deployed. You'll see on line 17 here where there's a reference to the repo. This is the reference to that ECR repo that basically says, when I deploy this service, where do I get the image from? And that resolves how and where it gets deployed. And then you do get some configuration in the service part of this experience where you're setting up the ports and so on. There's no magic. This is really more just EKS's way of deploying environments. I really mostly want you to know that these are the per service files that you're going to go configure. Now, as part of this also, because we have these silos, we also have to figure out how we're going to route in these silos. And this is where EKS gets a little tricky. Just in a chalk talk about this, in fact. And there are lots of different technologies and tools inside of EKS to consider for routing. I'm going to keep it simple for the moment. And this yourservice.yaml is also another part of our manifest that sets up the routing here. So here I've used Nginx as my router. And as part of onboarding, I have to set up the route for each new tenant as they get onboarded. So when I can't just say, hey, you're onboarded, start accepting and authenticating users. Somehow, when that user comes in, I still got to get them routed to the right namespace. So we can't really dig into the details of that right now, but just imagine for each one of those silos, as part of onboarding, I've got to also configure that route on the fly. By the way, all happening dynamically as part of your onboarding process. Okay, so now we've got our app deployed, we've got our control plane there. Technically, we could run our app, but I would say if I were migrating, I definitely would want to think about what are the other bits of the control plane, how far do I want to go with the control plane, how much functionality I want. And this is where I said I would like to see you focus a little on metrics and building out a good metrics aggregation service inside your control plane, because I feel like, especially in these early stages where you're migrating to this model, you're going to want to build this out. The good news is, all kinds of tools in this space that will aggregate this data for you. Kinesis will aggregate it, Elasticsearch, whatever tool you want to use here, like lots of great rich analytics tools. But you have to pull this data from somewhere. You can pull some of the compute and some of the other data from AWS sources like CloudWatch or through X-Ray, but you're also going to have to instrument your solution. And this is back to those helpers I talked about earlier, where you need helpers that can publish this metrics data. And then we need billing, right? So assuming you're using some third-party billing service, well, you're going to have to go set up an account for that. You're going to have to configure whatever plans you're going to use, whatever billable units. Are you billing on consumption or features, whatever you're on? And now, during our onboarding process, guess what? Another new capability needs to get added to our control plane. Now we have to add some kind of billing service here to our control plane. So now when I hit the web app and I onboard is also, in addition to creating a user and creating a tenant, it's going to go create a customer in the billing system. So that we have that tenant now registered as a new tenant customer inside that billing system. And once that's created, I start consuming this application in the silo, we'll send this tenant activity data that is saying, hey, what's going on in the system? What's the billable event that's happening that I want to send over to the billing system? And our billing service in the control plane will send that data along to the billing provider. Now, here's where you decide how much you want to aggregate inside the control plane, or how much of this is passed through from your control plane into the billing provider. That's kind of up to what your billing experience is at. But you can see, like, we're slowly building out this billing, this control plane to try to make it more and more robust to support more and more of the full spectrum of a SaaS experience, with the idea that, yes, eventually now the app plane is going to come along the rest of the way with us. One last piece of the control plane. This one's super optional, but I talked about the system admin user being able to log in and setting all that up. A lot of people will build an admin console so they can go in and manage tenants, and they can have a whole UI that's do this. They'll build their own app, and to get into that app, you're essentially authing against that system admin. Some people will do this all with command line, but I see people building very custom dashboards that let them see per tenant information. They can manage and operate tiers, configure policies, and so on. Okay, to me at this point, the good news is you have an MVP. Like, you're ready to take a SaaS product to market. Hopefully, we haven't rewritten too much of the original solution to get here. And hopefully, at the same time, we've built a good enough control plane that we can manage and operate this environment and function like a SaaS business, and that we set the stage to tell the business, go ahead, start selling, start engaging customers, start delivering, and we have an experience that the ops team can deal with. And now we're in the best position we could ever be in, because we're to market, we can get feedback from customers, we can turn the crank on all these other parts of the business that need to learn how to sell and market and do whatever they have to do with our SaaS solution, and we can now start to incrementally enhance this experience and begin to modernize it. So let's look at what that modernization experience looks like. And for me, the way I like to do this now, gets a little more, again, into a debatable area. For me, I like to use like this sort of strangler pattern. I don't know if you're familiar with this. I'll sometimes call this service by service migration. What we want to now do is start looking into these this code of our existing system and saying, where are good services we can start to carve out and turn into fully modernized services and build them like the greenfield kind of service we would have built if we were building this from scratch. And I can tell you the hardest part of this will be finding something that you grab that doesn't bring 100 other things with it. There's just no magic to this. You have to make some compromises here. Sometimes these services are more coarse-grained at the beginning because you just can't pull them apart. And so maybe the first step is they come across as this more coarse-grained service, and then 6 months from now you learn enough about that service that it decomposes a little more and you get the flexibility. But if you can create enough momentum as these things start to come across, it becomes kind of an avalanche, and suddenly it gets easier and it gets easier to carve out more and more microservices. The other piece that may not be so obvious in this kind of eye chart of a diagram is that you'll notice that this new microservice that I'm carving out is a siloed microservice. It's still dedicated per tenant. So it's still not truly a multi-tenant microservice yet because it's running in a siloed model. To me, this could be a good intermediate step because it doesn't require you to bite off everything to make all the routing and everything else to make it multi-tenant at first. So sometimes think this is a good first step, but you could debate that you could introduce this as a true full multi-tenant microservice as your first step. That's sort of a subjective point. So what does it mean to create a modernized service? Well, we've all really sort of hinted around all the moving parts of this, but really what I really want to do is I want to say, hey, this service is going to get this JOT token, and if I write this microservice, I'm going to write this microservice in a way that takes advantage and integrates with the control plane and maximizes everything we're trying to achieve operationally, but also provides the isolation, adopts the data partitioning, adopts all those other strategies, and we'll look at those in a second. But at a minimum, it's going to do some of the same things we talked about. When it logs, it's now going to call that log manager, same log manager we built when we migrated. Now this new code can just pick this stuff up and use the token manager to go log. And if we want to go access data that's stored in a tenant contextual way, I can go to the token manager, say, get me the tenant ID, go to a repository, and then get to the tenant data that belongs specifically to that data. Now, I can only show you a snapshot of what multi-tenancy here is, but we can look at a few more moving parts that are kind of around this microservice to give you a better sense of what we do. But first, I want to sort of say, well, what would it look like instead if we carve this out as a pool? Now, I'm supposing do it siloed first, then move it out as a pooled service, and now have it function in a full multi-tenant model where it needs that multi-tenancy to operate. It's going to actually be processing requests from multiple tenants at a time. So now you have to have all the pieces in place for this to function as a multi-tenant environment, and you have to have new routing in place to deal with this. We'll look at that as well. But the piece that gets lost in this is, we carved out our new pooled multi-tenant microservice. Your existing services that are in your current application that are on the left and the right-hand sides here will probably still have some interactions with this new pooled service. So you now have to figure out how to wire those interactions as well. So one of the things we have to do for this to be pooled is we've got to, our unit of isolation before was the full stack. It was much easier to say how one tenant was isolated from another. I could just prevent cross-tenant access across the namespaces. But now tenants are running inside the same compute, and they need isolation context here, but they don't know on a call-by-call basis. It could be a different tenant. So what we have to do here is what's called runtime isolation, where the code in your solution running in this service, whichever compute it is, that compute is deployed with a really broad context to support any tenant. And what we need to do now is go out, and this is where we got this thing. You can go check out our token vending machine, which essentially says, I'm going to go out. There's going to be an IAM policy out there that has the context of what my tenant's allowed to do, in this case, access some DynamoDB database. I'm going to assume role for that tenant context, and I'm going to get a set of credentials back. So those credentials will come back to me, and when those credentials come back, I will then use those credentials in this service and have this access context that is represented by these credentials to go access my DynamoDB tables, and now my new modern fully pooled microservice has isolation applied to it. And for me, this is essential to like bringing this multi-tenant piece to life. A lot of people in migration will leave isolation out of the story, just be happy that they kind of got that it's pooled and shared. You have to think about injecting this isolation story in here. The other parts of this is, are you going to think about how your data might be represented? The natural thing would be to think about maybe just having separate data as you bring it over. But now as this data comes over and comes into our multi-tenant microservice, we have a choice. Like, what do we want to do with the storage now that's in here? We could have the data pooled like I've shown here, and now this microservice could pool it all. And that will, by the way, the isolation story of that microservice needs to support the fact that it's pooled. Or I could have data that's siloed for tenants. So the compute could be shared for this, but the data could actually be siloed. Well, now in my microservice, I've got to like take that tenant context and figure out which DynamoDB table I'm interacting with. These are all the little nuances of bringing these first microservices to life that you want to support completely out of the box, so that once you get this figured out for one microservice, the next one and the next one sort of get easier. It's sort of setting the blueprint for what it means to migrate these in. The other thing is here, we're going to have to update our routing model. So now that we've got the pool running alongside our other environments, we have what we just talked about earlier, which was our original sort of environment. We're routing to these two very distinct namespaces where all the code was. But now we have this extra new service that we created. It's running here. Our provisioning has to also figure out how to configure the routing for that. And so here we have to have separate routing rules that allow inbound traffic to go to that pooled environment as well. And by the way, I didn't introduce that before until now, but you'll see there's a pooled namespace there. In reality, like there's a namespace construct that will be used to run all of our pooled resources. So you'll have siloed namespaces and you'll have pooled namespaces. And as you're making this transition, you have to route to both. Now, the good news of this is, once you have these constructs in place, you actually have some interesting options available to you. As you start creating more and more microservices in this new model, you can decide, are some of these siloed or some of these pooled? Because that's the real life. If you were starting greenfield, it isn't always all or nothing. So now as we're moving more and more away from our silo model, we get to choose which services are running in a siloed model and which services are running in a pooled model. And I don't have time to dig into it, but that could even be a tier-based decision. I might have some tenants that are my platinum tier tenants who get everything running in a silo, and then I could have basic tier tenants who are getting everything out of a pool, or I could have mix and match those concepts. The key here is that you see like I have order and catalog running in siloed model alongside my old environment for a tenant namespace, for tenant one, but then I've got this pooled namespace where product, ratings, and search are running. And those are all being shared by all tenants here. So I'm also starting to get all the economies of scale out of that environment because those resources are shared, these are all scaling based on the actual load of our entire multi-tenant environment. The value of this may not seem so obvious as we're migrating, but I truly think as soon as you start getting comfortable and you have a handful of microservices carved out, you're going to start asking yourself, wait a minute, I got this new microservice, but not every new microservice necessarily needs to be pooled. Some of these still need to be siloed. And of course, this affects our provisioning story. So our provisioning service, if we're going to do this model, means that now it has a much more exotic set of considerations. It's got to, for basic tier tenants, it might need to go and deploy an entire pool tier tenant and point those tenants there, route tenants there successfully. Maybe I have an advanced tier tenant that just has service 2 and service 3 as siloed because maybe those particular services are some high value area that we want to offer a silo. And I could have a premium tier tenant and now they get everything siloed because that's somehow the value prop that we have here. These are super extreme cases, not likely exactly how you're going to carve it up. They're meant to just represent the extremes. But I want you to sort of think about the fact that now that you have the freedom in this space to sort of mix and match these things, you have more options to offer the business more capabilities here and more ways to reach new segments and new customers. Now, once you have all these bits here, you've got your old legacy running, you've got this pooled namespace, you've got these other bits here. Really, if you take away this last sort of piece and you've moved the last microservice, the last bit of functionality out of the old environment, This is essentially that diagram that we said was our target end state that we were after. We're all microservices now. They're all modernized microservices. They're all implementing isolation. They're all implementing data partitioning. They're all instrumented and sending data to the control plane around metrics and billing and activity. And now it's just a matter of how much more you want to build it out. But hopefully, I really hope one of the key pieces that you take away from this is you'll notice that once we got the control plane up and going and we start moving the app plane along, the more we bring that app plane along, the more we get those microservices, the more those services that are sitting in the control plane sort of waiting for us to feed them all this nice context, to manage the environment, the better overall experience you're going to have. But that control plane really spans both that initial MVP and your modernized experience. So just a few takeaways here. Hopefully you can, for me, thinking incrementally in this whole modernization story is key, right? Somehow you got to put the context of where the business needs to go. What does this whole transformation story mean? Factor in that into how fast you're going to move to SaaS, and expect that we're going to set ourselves up for incremental improvement along the way, but at least we're going to get customer feedback. We're going to get the business moving in the right direction. I think I've beat this one to death probably, but hopefully it's very clear that the role of the control plane here, and if you're going to start somewhere, greenfield, migration, whatever you do, start with the control plane. And make this whole notion of onboarding and tenant-aware identity. You could see how that tenant-aware identity and that JOT token, which was a really simple thing, but the automation of the creation of that tenant and the creation of that authentication experience and the return of the JOT out of that suddenly meant all of our microservices had the ability to implement isolation. They could implement data partitioning, all by just accessing that JOT token. Don't go into the migration with the idea that we're pretty much not touching your existing environment. You're going to still have to, even though we're saying lift and shift as best we can, run to the full stack silo, code is going to change there. It's just a reality. And to me, the more you sort of leave it as is and the more you don't connect it to that control plane, the harder it is going to be for you to support it. And then don't be afraid of full stack silo as a starting point. Sometimes people kind of cringe about that. And it's like, but we want to go to SaaS. We want all this shared infrastructure. We want to have this great scaling experience. You're going to get there, but full stack silo is a perfectly reasonable point. And by the way, even if you started as a greenfield and were fully pooled on the beginning day, most of those organizations still end up with some customers running in a full stack silo. So if you think you escape full stack silo, you probably won't. There's some customer will probably still demand that. And then just know that like these first two microservices you cut out, the first few ones you modernize, like I said, the scope of them is going to be hard to pull out. The getting all that wired up and getting it working and getting those first few to come across is really hard work. You just kind of have to stick with that and then just wait for, like imagining more and more of the stickiness of those services pulling apart and more of the stored procs going away and less and less of this sort of web of dependencies on the monolithic database going away, and suddenly it like starts freeing up and moving better. And then like don't try to be perfect here. You're going to get stuff wrong. Like you're going to pick the wrong service. You're going to get the wrong granularity. Like things are going to happen here. Don't like get paralyzed by that. Just move and figure it out as you go. And then whatever you do for these new microservices, don't compromise on these new microservices. They are the long-term view of how you want the system to be built. So set a really high bar for those and figure out what exactly you want them to be and expect them to be as a fully compliant, multi-tenant aware microservice. Okay, we're on Thursday, so I don't know how many of these sessions are left, but we did have some awesome workshops, so even if you didn't get to attend them here, I would encourage you to go check them out. I did say there's reference architecture, so I'm going to cheat and go right to this slide because this has QR codes on it that'll get you to reference architectures, blog posts, white papers, all the good stuff you would expect. And I'm going to leave that slide up for a little bit here, but I'm going to go ahead and wrap anyway without my thank you slide. So really, I know it's the end of a long day and nearing the end of a really long week. I really appreciate making the time to come out for this. I hope this This was a bit of an experiment, honestly, for me to figure out showing one end-to-end path and whether that would be helpful or not. So I hope you got value out of this, and enjoy the rest of your reInvent. Thanks so much.